Hello, and welcome to tricky GCSE Maths questions. This time I'm going to have a look at one about circles on a graph. This is taken from an Edexcel paper in 2019. So let's get right into it. So here's the question. We have a circle on a graph here, and we can see we've got some points marked, and we've got a line along here, and we've got an angle marked. So reading that question and having a look at the diagram, the first thing that springs to mind here is that we have a circle on a graph. So thinking what that might mean, x squared plus y squared equals the radius squared, the equation of a circle on a graph. That might be relevant, so I'm going to write that down. Okay, so read forward then. AB, that line here, is the tangent to the circle at the point A. So a tangent being something that touches the curve of the circle and never touches it again. So just one little sort of hits the side of it and glances off. So thinking about that and thinking about the fact you've got a circle, you might be thinking back to your circle theorems, and you might be thinking, well, my radius meets my tangent at a 90-degree angle. But there's something else that is relevant. And we have an angle over here. So my head is saying I've now got a right angle triangle and I've got an angle. Is this going to be about trigonometry? Moving on then, point B has the coordinates 16, 0. So this is the point 16 here. The length from here to here is 16. This is our radius. And point P has the coordinates 3p, p. Find the value of p. So this is what we're trying to find. And some key points here as well. Give your answer to one decimal place and you must show all your working. So this is a calculator question, but it is asking us to show all of our working. Right, so starting with that triangle then, that seems like a good place to start. It's the bit where we have the most information. We have a triangle with 30 degrees. There is 16 across here, and we know this is our radius. So let's start labeling it up for trigonometry. So we know this is our hypotenuse. It's opposite our right angle. Opposite the angle we've been given is our opposite. So we should be thinking now our trig ratio is the sine of the angle is equal to the opposite over the hypotenuse. So let's put in our information. We've got sine of the angle being 30. Our opposite is our radius and our hypotenuse is 16. Now I may remember from when I did my non-calculator papers that sine 30 is a half, or I could pop that in my calculator and it would tell me also. So a half, which is the same as sine 30, is the same as the radius divided by 16. I can use equivalent fractions here, or I can just times it by 16. But either way, that will tell me that my radius is equal to 8. 16 times a half, or looking at equivalent fractions, 2 times 8 is 16. So 1 times 8 must be the radius. So my radius is 8. Now, where is that going to be relevant to this point over here is that I also have a radius running along here, straight from the centre to the point on the outside that I'm trying to find. And this is where x squared plus y squared equals radius squared. These are my x and y. If I've got a coordinate, I've got an x and a y. So going back to x squared plus y squared equals radius squared. So I've got x value and my coordinates is 3p. Oops, sorry, not 3y. Just change that. 3p. My y is the p. And I've got a radius of 8. So let's pop all that information into here. So 3p squared, and this is one place where we might make a mistake. It is all of that is squared, especially when we're rushing during an exam. It's easy done. Y is p squared. And my radius is 8, so that's 8 squared. Okay. Then remembering now that I'm going to have to square all of this, so 3 squared is 9, and it's p squared, plus a p squared equals 8 squared. Let's simplify this section here. 9p squared plus another p squared is 10p squared. And that is equal to 64. 8 squared being 64. Let's start to solve then. So p squared, we're dividing by 10 on both sides. So this is 6.4. And we're now going to square root both sides. So p is equal to, and if I pop that in my calculator, I'm going to get 2.52 dot, 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 dot. I'm going to carry on. So it's asking me for one decimal place. So my answer to this is going to be p is equal to 2.5. And now I have all of my information and I've answered my question and I've shown all of my working. So how does that compare to the mark scheme? Where am I getting my marks? Let's have a look here. So my first mark here is for using the trigonometry. So some kind of use of the trigonometry, whether that is saying that sine 30 is a half, to then find that OA is 8, that side that we're looking for, the radius. And then, or some sort of stating of 16 times sine 30. Okay, that use of the trigonometry is getting me 1 mark. The second mark is for linking that then to the equation of the circle. Now notice on this side here we've got except 3p squared plus p squared equals r squared for this mark. So this is incorrect substitution because we know this should have ended up as 9p squared, not 3p squared. We've forgotten brackets here. So in that case, we would have got the second mark. However, reading down to the third mark, correct substitution, this is where it would have mattered. So it needed to say 9p squared or 3p squared in brackets. We can no longer accept that for the correct mark here. And this here is in little quote marks because if we've made a mistake here, it would be unfair to penalise you twice for having the wrong information here. So say you'd accidentally tapped that into your calculator wrong and you got 7, for example, as long as you used it correctly in this formula, you would at this point have that third mark. Final mark is for the answer in the range of 2.5 to 2.53. It is quite generous here in that it's allowing you, despite the fact that it said that it needed to be rounded to 1 decimal place, if you've rounded incorrectly but they have seen the correct answer in the working, you would still get 4 marks. But this is the key point for that last line: awards 0 marks for the answer without supportive working. So if you did not show your working, you would have received 0 marks even if you had done everything correctly and got yourself to 2.5 at the end. Okay, hope that helped, and I'll be back soon for more tricky questions.